Hi, in this video, we are going to launch a new course on mechanics for JEE Advanced and Physics Olympiads. So the purpose of this course is to handle all types of problems on mechanics and basically give you the theoretical foundations as well as teach you different types of problem solving techniques that are important from a JEE Advanced perspective. Also, the contents of the course will sometimes become slightly more advanced than JEE advanced level and might even approach the physics Olympiads level. So students who are preparing for JEE as well as national and international physics Olympiads can also learn something from the videos in this course. Uh, right now I'm building this course for mechanics. After that, I will move on to the other topics of physics as well. It will take a few months and hopefully I will have a full set of courses for physics Olympiads and JEE as well as maths Olympiads that I've already been bringing you to you. So let me just go over the details for this course. So uh, this course is about mechanics. So I will outline the course content. The first chapter that we are beginning with is statics. Statics is basically the situation when bodies are at rest, and we are going to understand forces and torques and how statics works. Each section of the course, these are different sections. Each section of the course will have some theory videos. So there will be theory plus several problem solving sessions. And I will try to cover as many of the previous year's questions that have appeared in JEE or in physics Olympiads as possible. So this is the first chapter. Then we get to F is equal to ma, basically Newton's laws. That will be the second chapter for the course. After Newton's laws, we go to the chapter on oscillations or simple harmonic motion. Slightly early for simple harmonic motion, but the analysis that we'll do there will be useful because we'll be using that sort of analysis later as well. So simple harmonic motion or oscillations, that will be our third chapter. Then the next chapter is conservation laws, conservation of energy and momentum. That will be chapter number 4 for us. After that, we go over to central forces and gravitation. Central forces and gravitation. So this is also a mathematically important chapter. It will involve, just like simple harmonic motion chapter, it will involve a lot of differential equations, and we learn the mathematical basis for gravitation and problems involving that. And then finally, we end with a deep dive into rotational mechanics, which will cover angular momentum conservation principle, and all about rotational mechanics. So that will be a slightly longer chapter. On the way, we will also cover things like non-inertial frames of reference and maybe even a bit of vectors and tensors. So from the point of view of Olympiads, I will talk about a little bit of vectors and tensors also towards the end of the course. So roughly 6 chapters in the whole course, and we will start off with statics and go over to these chapters in this particular sequence. Every chapter I will try to bring detailed theory discussion and also problem solving videos. So you can expect around 5 to 6 videos per chapter in order to fully cover the contents. And I will try to cover as many of the previous year's questions from JEE Advanced which have appeared from these chapters. So that's the rough plan for the course. Uh, So stay tuned for the videos coming up on the channel about this, and hopefully you will enjoy the course and you will learn from it. This will be relevant for students who are appearing for the JEE in 2025 or 2026, and any students who are also appearing for the physics Olympiads exams towards the end of this year or next year. So those are the prime students who should take advantage of this course and learn from it. So that is the rough outline. Now what we will do is we'll begin the first section of the course, which is statics. So this will be a purely theoretical video. I will bring the problem solving videos on statics beginning from the next video. So today what we will discuss is what is statics, what is the subject of statics. So basically, as the word suggests, statics is a situation where all objects are motionless, or all objects are motionless in statics. And here you have to understand, if an object is motionless, then according to Newton's second law, which we will see later, F is equal to ma, guarantees that the total external force acting on the object must be zero. Implies that the total external force on the object must be zero. Why is it guaranteed? Because if the total external force is not zero, then there will be acceleration in the body. And if there is acceleration in the body, then it will not remain motionless, right? However, you should understand that the converse of this statement is not true. Converse is not true. So what do I mean by that? If an object is motionless, the total external force must be zero. But if total external force is zero, does not imply that object is motionless, right? Because object could be moving at a uniform velocity, and you could have v constant, and that would be a case of an object which is moving, but the total external force is still zero on it, right? So you have to be careful about these things. So we will not deal with the situation where the object is moving, because right now we are talking about purely statics, right? So in this statics situation, what we will have to do, the entire goal in a statics problem is to find out what the various forces have to be so that there is zero net force acting on each object. So for statics, you have to do a force analysis and figure out how the net force on the object, net force, and sometimes you will also see net torque. Net torque on an object is zero. If the net force is zero, the object can remain static. If the net torque is zero, again the object will not turn. However, it is possible that you have net force is zero and the object is still moving. The converse is not true. However, we will discuss the situations where net forces and net torques are adding up to zero, right? Now, before we do any analysis of static situations, you need to be familiar with all the types of forces that you might encounter. So we will do a quick summary of what are the different types of forces that you might see. The first kind of force that you might encounter is known as tension. So what is this tension force? So tension force is the general name that you give to a force that a rope or a stick exerts when it is pulled on. Exerts when it is pulled on. So tension is the force that a rope or a stick will exert when it is pulled on. Now what happens is, if this is like a rope, and let's say we start pulling it from here with the force F, then every part of that rope, every piece of the rope feels a tension force in both the directions. Every piece of the rope will feel the tension force in both the directions, and basically the rope will get tightened, and finally it might start looking like this, where you're pulling it like this, and it is fixed to a wall or something here, right? So each and every part of the rope will experience a tension here like this. Every part of the rope is being pulled from both the directions. The only places where this is not true is at the end point. At the end point, this point is being pulled technically in one direction by the rope, and in the other direction, it is going to experience an equal and opposite reaction force from the wall, right? Because otherwise it would have come out. So except for the end points, every point in a rope will experience tension force in both the directions. Now, in some cases, you will see that tension may vary across a rope, may vary across the rope. And in some cases, you might find that tension is the same throughout the rope or remains same. So how will you figure out when is the situation where tension varies and when is it that tension remains the same, right? So that is something that you should think about. So for example, if you have a rope that was hanging from the ceiling and this rope had mass, we are saying that the rope itself has mass, then you will realize that the tension in each of these parts is different. The tension here, T1, T1 is different from the tension here and is different from the tension here, because if you think about it, if I take the free body diagram as the entire portion of the rope below this point, then this T3 is supporting the weight of the entire length of the rope here, right? And that weight would be larger than what would have been the weight of this portion of the rope. So as you go higher up in the rope, the tension increases because the tension force has to hold up a longer portion of the rope against the force of gravity. It is the tension force that holds up this lower part of the rope and makes it not fall towards the earth's center, right? Because gravity is pulling this rope with mg force and tension T3 is stopping it. So obviously if the rope had mass at different locations, here the tension is only stopping this much of the mass, right? So the weight will be like some m2g here. However, here the weight was some m3g, which was the weight of this portion of the rope, right? So in this situation, you are seeing that tension is varying, right? However, there are other situations where you will find that tension is constant. For example, let's say we have a light rope. We have a light rope and this light rope is going around a massless pulley. Massless pulley. Now, obviously, there is tension in both the portions of the rope. This portion of the rope, there is tension T, and this portion of the rope, there is also a tension T. I could say T1 and T2 are unequal, but what I will argue here is that in this case, if it was a massless pulley and a light rope, T1 will be equal to T2, will be a common tension value. Why is that so? The reason it's a common tension value is because if the tensions were unequal, what would have happened? There would have been a net torque. Let's say T1 was greater than T2, then there would be a net torque which tries to turn the pulley in this direction. The net torque is T1R minus T2R. And this torque should be equal to I alpha for the pulley, where I is the moment of inertia of the pulley. And now this total torque divided by I should give you the angular acceleration of the pulley. But if the pulley was massless, Moment of inertia of the pulley is 0 because usually moment of inertia is defined as the sum of mi ri square, right? We will discuss these concepts in much more detail when we come to it later in the rotational mechanics part of the course. For now, don't worry about the details so much, but realize that moment of inertia depends on mass. And if moment of inertia of a massless pulley is being calculated, it has to be 0. So if moment of inertia is 0, you are getting alpha tends to infinity now, right? You will get an infinite angular acceleration of this pulley if the tensions were different, T1 and T2. Right? However, that doesn't make any sense. In any physical situation, you should never have infinite acceleration or angular acceleration. So therefore, tension in this case remains same throughout. Taking the other example, if it was a rope like this which was hanging and it was a massless rope, obviously you should say that now tension here is the same as tension here. If this tension was T1 and this tension was T2, T1 and T2 cannot be different from each other, because if T1 and T2 are different from each other, there must be an element here where one side the force is T1 and one side the force is T2. And then if they are unbalanced, this element here will have acceleration. But when you calculate the acceleration, T1 minus T2 is equal to m times A, the element was massless again because we had said that the rope was massless. So again, you will get infinite acceleration. Because element is massless, the tensions cannot be different. So that is your basic introduction to the tension force. Understand that a rope always pulls using tension force. A part of the rope will pull the other part of the rope. It can never push any other part of the rope or any other body. You cannot push a block on the ground by taking a rope and trying to push through the rope. What you can do is always pull. So tension is a pulling force. So you should realize that. The next type of force that we'll talk about are normal forces. So what are these normal forces? So this is the force perpendicular to the surface that a surface applies on an object. So technically, the surface here applies a force on the object which could be in any direction. This is known as your contact force. It is not necessary that the contact force is vertical or horizontal. It is not necessary all of that. The contact force could be in any direction, and we take the vertical component of the contact force, the y component of contact force, to be called the normal force. The x component of the contact force is known as friction. So if you split the contact force into two parts, you can break it apart into two components, normal force and friction. So that is the origin of your normal force. Now, what is the fundamental basis because of which the normal force is acting? Basically, the normal force comes about because the surface is actually compressing a little bit and will act like a very rigid spring. So when you are putting a block on the ground actually bends down a little bit due to the weight of the block, and this whole ground surface will act like a very stiff spring which pushes it back up, and that push force manifests itself as a normal force, right? So you can think of both the tension forces and normal forces like and model them as tiny springs. The only difference between the tension force, which was like in a rope situation or in a pulley situation, the tension force is always modeled by using a spring which has been extended. Tension can be modeled by thinking of it as an extended spring in every part of the rope, because of which every part of the rope pulls the other parts of it towards itself, because the extended spring wants to come back to its natural length. That's why there is tension there, and it is pulling the other parts of the rope inward. On the other hand, the normal force is like a compressed spring. The ground behaves like a compressed spring, so it wants to push back. This is a pushing force which tries to bring the ground surface back to its natural state, or the equilibrium state. So that is the fundamental basis for your normal force. Friction is another force that you will encounter very frequently in problems in statics. So friction is basically the horizontal component of contact force. Horizontal component of contact force from the ground. From the ground. Now, the friction can be of two kinds. It could be static friction, which is what we'll mostly be focused on in this chapter, and it could also be kinetic friction. Static friction arises in the case when the body has no relative motion with respect to the surface beneath it. With respect to surface beneath. And kinetic friction happens when the body has a relative velocity with respect to the surface beneath it. Surface beneath. And what you have to keep in mind is friction always acts in such a way, always acts to oppose the relative motion between the two surfaces. Relative motion between two surfaces. So in the case of static friction, if you are pushing a block with some force on the ground and the block has not moved, it is the static friction which was acting in the opposite direction to prevent relative motion between the block and the ground. And that static friction is what has stopped you from pushing the block across the floor. Now, it is obvious that you can obviously change the strength by which you are pushing. And you might realize that there comes a time after which you can push with enough strength to make the body move on the surface. Okay? So from there we can figure out that the static friction force has an upper limit or a maximum value, and otherwise it can adjust its values from 0 to that maximum limit. So we will later see that static friction F of S is less than equal to mu S times the normal force, and equality happens when the body is just about to slip. When the body is just about to slip on the surface. And you need to be very careful about what you mean by the word slip. Slip means have relative motion with respect to surface below. If it has relative motion with respect to surface below, then that is your slipping. So static friction values are always less than equal to this and less than equal to 0. So for example, if I place a block on the floor and apply no force on it, then obviously there is no tendency to make the body slip. So therefore the static friction in this case is 0. However, if I apply force of 5 Newton, maybe the block was 10 kg, and if I put 5 Newton force from outside, the block still doesn't move, in which case the static friction has become 5 Newton, which is opposing the slipping on this surface. Similarly, if the force was greater than the mu n, mu static into n, if the force was greater than that, then definitely the body will start slipping because there is acceleration. Once the body starts slipping, what will happen is now there will be kinetic energy that starts acting instead of static. Kinetic friction starts acting instead of static friction, because kinetic friction is what happens when there is relative motion between the two bodies. And you also have to keep in mind that kinetic friction, the value is always constant and it is mu k times n. This value remains fixed, kinetic friction value. So that is about your tension force. The next force is the force of gravity that you will encounter a lot of times. Okay, we have covered tension, we have covered normal force, we have covered friction, and now the next one is the force of gravity. For now, because we are just beginning our mechanics course and we have not discussed gravitation, we will assume that the force of gravity acting on any body of mass m will be small m times g, which is pointing towards the center of the earth. It's a vertically downward force. In reality, we can write it as actually g m1 m2 by r square, where m2 is the mass of the earth, m1 is the mass of the body, and r is the distance from the center of the earth to that body. Now, we will later understand this formula from a field point of view, gravitational field. For now, you just need to realize that we will not be using this formula directly, but mostly be working with the weight of the body, which we are familiar with. The weight of the body is the force by which the earth is pulling the body. And if you think about the Newton's third law here, you should also realize that if earth pulls the body with weight m1g, then this mass also pulls the earth upward with force m1g. Because Newton's third law says that there is equal and opposite action reaction pairs, right? So gravity usually is constant. The small g that we use in this equation F is equal to mg, the small g is technically g capital M by r square, where capital M was mass of the earth and re was the radius of the earth, right? So radius from the center to the point where the body is. So that is your force of gravity. Now, one important thing you need to realize is in any statics problems, you have to approach it by doing sum of all the forces should be zero and sum of all the torques should be zero. And when you calculate torques, you can calculate torque about any point. Torque about any point in the system should be zero, because it is not possible that the body can have an angular acceleration about any point in that system. Torque should be zero about any point, because if it is non-zero, then the body will start spinning about that particular point. And in order to calculate torque, you should employ the use of vectors. And torque is defined as r cross f. Here, you should be clear about what r means and f means. R is the position vector from the point about which you are taking torque, about which torque is being calculated, to the point of application of the force. Point of application of the force. So if I have a rod like this and it is pivoted to the wall like this, and my force was applied here like this F1, and one force was like this F2. Now if I want to calculate torque about this point O, I have to make a vector R1 from point of application from the O point, the origin about which the torque is being calculated, from here to the point of application of the force, that is your R1 vector. And from here to the point of application of this force is your R2 vector. So torque here would be R1 cross product F1 plus R2 cross product F2. That is what you get as the total torque on this rod. Now, when we look at problems in the upcoming videos, I would recommend that you try to solve the problems yourself. Once you have tried the problems yourself, you can pause the video till then and then look at the solutions. We will be discussing quite a few challenging problems, but you will never learn physics unless you yourself have tried the questions before. So I highly recommend that you pause the videos, try it yourself, and only then see the solutions that I will be presenting. So the theory for statics, I don't want to go into any more detail. It's all about problem solving and learning the tricks of the trade. So we will start with some problem solving videos about this first chapter of our course in the next class. And I will try and include all the questions that have recently appeared in JEE in the past few years, and as well as some tougher questions for Olympiads and all, which might help you get a better understanding of the concepts in this chapter. So stay tuned for more. I will see you in the next class with the practice problems on statics, and hopefully you will learn a lot from this course. If you like the content, please subscribe to the channel and share it with your friends. Your support and your encouragement is what drives me to provide content like this. So I need your support. Please like it. The algorithm works better and it can be seen by more students if you like the videos and subscribe to the channel. So see you next time, and we'll continue with this mechanics course for JEE Advanced. That's all for now.